And we're supposed to use the one hint that is given to us is that they gave us 1 0 here, and somehow we're supposed to find the rest of the zeros and then write the answer as the product of linear factors. So if we can find the other 3 zeros, then writing the product of linear factors shouldn't be an issue. Well, first off, how did I know that there's 4 zeros? Okay, biggest exponent is 4. That's what the fundamental theorem of algebra says. The degree tells you the number of zeros. Okay, for this type of question, the second one should be given to you. You have to know, especially for this type of question, because there's nothing else you can really do, that imaginary zeros come in conjugate pairs.
You should have to know that you can plug the I.
I mean, that's what a conjugate is.
No, I'm saying plug the I in front of the square.
Oh, yeah. Typically, we put I in front of the square root. The book puts it behind. The problem is, if you put it behind in your writing, like, if you do like that, I being under square root is not what we mean. So, if you put the I second, you need to put it way out here. It's a lot easier to just put it out front, and then there's no confusion. Okay, and then this is like number 4, I think, on the practice review that we did. So if I can divide out this 0 and divide out this 0, it's going to take it down to a 3rd degree and then a 2nd degree, and then I don't know how hard the 2nd degree will be to solve, but I do know that quadratic formula will work if nothing else. Now, I can't synthetically divide by these, and I can't long divide by these yet, because these are just zeros, not factors. So what I could do is change these guys into factors by doing x minus each one, and then distribute the minus. And you could divide out just one of these, then come back and divide out the second one. But if you do it that way, you're going to have i's all over the place, and it's going to be really hard to keep up with. So in our examples and our notes, what I suggested to you is let's divide out both of these at the same time by figuring out what these two look like if we were to multiply them together. So 3 things times 3 things is going to give us 6 things. Just be careful that you take x times all 3, negative 1 times all 3, and I squared of 2 times all 3. And let's see, positive times a negative would be negative. I times I is I squared, and square root of 2 times square root of 2 is square root of 4, but the square root of 4 is 2. Okay, so when we try to clean this up, all the i's should go away. So combining like terms, those go away. Leaves behind an x squared, a minus 2x, and then right here we have to remember if I is the square root of negative 1, then I squared would be negative 1. Square root of something times the square root of itself just gives you that thing. So this is really like a plus 2. So this plus 2 combines with this plus 1 and gives me a plus 3. So instead of looking at these two factors separately, I just multiplied them together to look at them both at the same time. Because it's going to be nice to only do one division, and this is much cleaner looking than this, so it's going to work out much better. Now, as much as I would love to do synthetic division here, you can't divide out quadratics using synthetic division. So long division is just necessary sometimes. However, I do know one thing about this long division. What is one part of our work here that should be a check? Something about the remainder.
0.
Right. If these are really zeros, and I didn't mess up the factors, and I didn't mess up the multiplying, and I don't mess up the long division, these should divide into this evenly. So at least I have this check that to divide into it evenly, it should have a remainder of 0. So, looks like a very unfriendly long division question, but it should actually be just fine. So x squared, because x squared times x squared is what gives you x to the 4th. X squared times minus 2x would be minus 2 x cubed. And x squared times 3 would be 3x squared. Change the signs and add. Okay, and then start the long division process over again. Looks like the next part needs to be minus 4x, because negative 4x times x squared is what gives you negative 4x cubed. Also, negative 4x times negative 2x would be 8x squared. And negative 4x times 3 would be minus 12x. Change the signs and add. And I think I might have a mistake there, but I'll have to go back and try to figure it out in a second. The last part would need to be a plus 3, because 3 times x squared is 3x squared. 3 times negative 2x would be negative 6x. 3 times 3 would be 9. Yeah, I must have a mistake right here somewhere. Did you get this far in this one, Forrest?
Yeah.
Did you?
The negative 18x.
Uh-huh.
That goes down to 6x.
Oh, yeah. I just misadded right here. I was thinking 18x plus 12x would be 30x, but negative 18x plus 12x would be negative 6x. So again, it helps knowing that the remainder is supposed to be 0, because it helps me catch that little arithmetic mistake. Okay, now it looks fine, because if I change the signs and add, all of it goes away, and I got that remainder of 0 that I was wanting. So what this just tells me is I just did the long division correctly, I changed these zeros into factors correctly, and I multiplied those factors together correctly. So that just checked a ton of work for me. But I did all of this, I divided these two out to expose this hidden quadratic within this hidden 4th degree polynomial. Now I just need to solve it to get the last two of these. So of course I'm going to hope that it factors, but if it doesn't, I can use quadratic formula. Looks like the last two factors are 3 and 1. And then the question says, write your answer as a product of linear factors. So our function is this factor times this factor times this factor times this factor. Product, because they're all being multiplied. Linear, because the biggest exponent on x is a 1. And factors, because all 4 of those things would divide evenly into the original polynomial. Did you find your mistake in there that you needed?
Yeah, I helped to know that you can pull out the I from the square root of 2.
Yeah, I mean it shouldn't matter.
Because I was multiplying square root of 2i times square root of 2i.
Okay, so you were working it like the I was under the square root. Yeah, that's the danger of putting I after the square root. I like to put it in front.